My name's Charlie Kepler. I work here at Headwall Photonics in our customer support division. I'm also one of our lead pilots.
I'm Carson Roberts. I'm a principal applications engineer at Headwall Photonics. I try and use our systems the way that our customers might. I spend a lot of time going out into the field and collecting data, trying to find new applications for the technology. Headwall is a manufacturer of components and systems based on diffraction gratings. We use those diffraction gratings to make hyperspectral imagers, capture imagery with them, and do spectroscopic analysis on the spectral imagery.
This mission, we wanted to, kind of as a proof of concept, take the nano hyperspec instrument into the field and do some ground truth scans with the tanks that had the coral inside that they were rehabbing to go be outplanted back into the ocean, and then take that same instrument and put it onto the M300 UAV.
My name is Marion Biddle. I'm a staff biologist at the coral restoration team here at Mote. I see 2 or 3. Anything from fragging to daily husbandry tasks of algae mitigation and siphoning to coral feeding.
These are the guys that are still kicking, and some of them doing surprisingly well in wake of the heat wave last summer.
Hyperspectral imaging is potentially useful in any situation where there are objects in the scene that have characteristics that show up as spectral features. For example, I'm surrounded by the green grass. That's a result of the chlorophyll in the grass, which is a chemical which absorbs and reflects light. And so there's a lot of people that have been using hyperspectral imagery to look at plant health. Essentially, by looking at the spectrum of a plant, you can get an idea of how much chlorophyll it has. The more chlorophyll a plant has in general, the healthier it is.
Hyperspectral imaging can help companies like Mote in kind of seeing things that the naked eye can't really see, detecting things early, differentiating different species.
It's really important to me that we protect our valuable resources.
The goal eventually is to have the ecosystem at the previously healthy state it was, and it to be able to sustain itself.
We've been able to identify multiple different species of toxic cyanobacteria in ponds, and again, this is a way of solving a broader problem of the harmful algal blooms and quantifying them, again, by remote sensing.
Because we're in a part of the Florida Keys National Marine Sanctuary, any construction or manipulation to the marine environment or potentially harming any of those sensitive marine resources have to be either mitigated, like if there is harm, so you'll have to pay for that, and or rescued. When we outplant these plugs here, we space them in about clusters of 10 of all one genotype, and once they grow out and grow onto and close to one another, they will then merge and form about a coral of this size. Once they get to this size, they're then sexually mature, and then they can reproduce.
Any coral that's been on land for more than 30 days has to be vet checked by a professional before it goes back out to the ocean. The reason why it's such an effective strategy is because you're essentially hanging these corals in the middle of the water column. So you're above all of the detritus and stuff on the bottom, you're not too close to the top, and you're maximizing on both sunlight and the nutrients that come by for their feeding. And then they stay there until they grow to entire plug size. And then those will get outplanted as well.
We cut them ideally anywhere from like 1 centimeter by 1 centimeter squared frags to larger frags, and we're still in the experimental process to figure out the expedited growth for those species.
These operations will need to scale incredibly in order to make a real impact on the environment. And it's not going to be possible for individuals handling individual samples to restore the coral reefs. It's going to have to be a big industrial scale operation, and this is exactly the sort of thing that hyperspectral imagers can really help with. So we're coming up on 1 hour that we haven't had the flow. Should we put a pin in it? Southwest quad, 30%, minus 50.
My name is Celia Lito, and I'm the Coral Reproduction Laboratory Manager at Mote Summerland Key Laboratory. And essentially I oversee all sexual propagation of coral at our facility, which is about a half an hour north of Key West. And this is our main coral facility.
So how do you actually split them up like that?
So, it's very complicated. We take a bandsaw and we move them through them. It's a diamond bladed saw, so it's friction based, so like you can nick your fingers on it and it, you know, it's like it won't cut skin or anything. We're kind of like hijacking their asexual reproduction. Corals, as I mentioned before, they're capable of sexual reproduction, spawning stuff we want them to do. But the way that they grow larger naturally is asexual reproduction as well, budding and lateral growth as the skeleton grows under them. Corals that are physically abrased in some way have an enhanced grow back period.
So every year I will program whatever conditions we want them to experience, and then they will spawn in captivity. And it's really special because we are able to complete a coral entire life cycle in-house, which is something that makes our institution and our laboratory unique. In 2023, we experienced the worst thermal event that the Florida's coral reef has ever experienced yet. And we were really worried about how our outplanted recruits would do, of course, because I'm a mother and I want my babies to do well, but also just what that means for the environment as a whole. And unfortunately, at least our specific area and a lot of different areas throughout the Florida Keys did experience a large amount of loss, specifically in aquaporids, so staghorn and elkhorn corals and branching species that you see behind me. Our 2020 and 2021 cohorts of Aquapora silvercornis and Formata had upwards of 70% individual survival and 100% familial survival, which is amazing, not only just out in general, but it's also great considering the terrible conditions that they were in. And that's showing that by strategically crossing specific parents that we know have desirable traits and making sure that we are diversifying that population, that we are increasing that adaptive potential. How effective those spawning clubs are is kind of under research. And the reason is because it's so hard to find these little babies, and it really depends on what time of year that you go out. So I imagine hyperspectral imagery would be a fantastic way to highlight where those recruits are. Keeping track of the genetic diversity in our lab and in our various nurseries and where those individuals end up is a very large task. And currently we are using a combination of our partners with Sea Foundry, which has been fantastic, for the restoration efforts. And then for our sexual propagation needs, because there's so many components that we have to keep track of, and there's multiple names that they're assigned, and how those individuals are distributed while still maintaining their familial crosses or their parental information versus their ID versus what ID they're given when they're given to a partner or ourselves is incredibly difficult, and we're working with Sea Foundry to try to make that streamlined as possible by expanding upon hyperspectral imagery and really fine-tuning how we're going to capture that data. That would reduce the amount of time, the amount of people that are required in order to create this one organ mosaic, from an image from the diver to the person processing it to someone actually analyzing it. That can all be streamlined.
Dr. Jason Spadaro, I'm the Program Manager for Coral Reef Restoration Research at Mote Marine Laboratory.
And I'm Scott McDonald, the CEO and founder of Sea Foundry.
Mote Marine Laboratory is a nonprofit organization dedicated to marine science, education, and restoration. We've been around since 1955, and are particularly, here we're working on coral reef restoration and research, specifically on Florida's coral reef, but on coral reefs around the world.
We're a technology company dedicated to helping organizations like Mote do their work better, faster, stronger, and we've been working together for the last 2 years, I think now, on all sorts of things, but in this case they've been doing a lot of really great work on measuring the ecological success of their work at a sort of a larger scale than has been possible in the past.
And that's where we saw an opportunity to see what Headwall could offer in terms of technology to help in that. What will be really great to see is different spectral signatures for non-restored and restored sites, and if possible, some of the species differentiation of what they've worked with in the past.
Developing a remote sensing capability that expands the scale at which we can do monitoring, and monitoring for predictive results is potentially transformative. Instead of using single species plots and focusing very heavily on genotypic level diversity, pushing the field of marine restoration and conservation forward, but also, personally giving our reefs a fighting chance of being there for the next generation of young scientists. Well, he knew that the previous outplants that we've done here were over here on the west end of the reef, so we wanted to make them disparate. If we're able to differentiate between live and dead coral, stressed and healthy coral, between species, potentially between genotypes within each species on the reef without getting in the water, and from an aerial platform, that dramatically increases the scope of what we can accomplish.
One of the wonderful things about hyperspectral imaging is, and particularly remote sensing, is that you can do things that may take an expert a lot of time to do, and you can do them automatically based on intrinsic properties of the things that you're looking at. And so in the case of the coral, I would hope that we'd be able to come up with some ways of automatically through imagery identifying species and genotypes of corals, and potentially being able to look at stress levels in corals and identify healthy versus unhealthy corals as part of this whole grand scheme of trying to restore damaged coral ecosystems. So the drone is right here, and it's on flight line 1, 2, 3, 4. It's on flight line 6. That's about halfway through.
Preparation for field missions is really crucial. We were taking off and landing from a small area on a boat with a, not the biggest, but also not a very small UAV. And to be honest, it was a little bit dangerous, and we only decided to do that because me and Carson had done some practice back at the shop. Spinning blades at eye level is not ideal.
The hardest part of the mission was catching the drone out of the air from the back of a pitching boat.
Exploring these new and innovative technologies, especially underwater. I imagine just like we saw autonomous drone imagery being taken, there's certainly autonomous underwater vehicles that could do the same thing, but without that challenge of the surface of the water. Data capture is obviously changing as technology increases and advancements are made with things like hyperspectral imagery or robots and neural networks and AI.
We're still chunking through the data. It takes quite a while just due to the sheer size. I've been primarily looking at the flight data, and Carson's been primarily looking at the lab scans. And kind of the intention is we will analyze the lab scans first and then develop a model and then take that model and apply it to the remote sensing data.
It's pretty special to see that kind of rig up in the air collecting data for this purpose, so there you go, Headwall.
Agreed. Thank you, Headwall, for coming out with us.
The most striking thing in the analysis that I've done so far, which is really very preliminary, is that there's some very strong fluorescence in the coral, and we can use those to differentiate amongst species. It looks like there's some very similar corals that look very similar to the eye, but have significantly different expressions of these fluorescent chemicals. And so I think that's going to be a part of figuring out which corals are which and potentially what is their health.
The sense of community and the ability that we're able to exponentially grow every year. For example, like with the hyperspectral imaging, with the Sea Foundry partners, with different, for example, gene swaps for us, like we will produce larvae, we give some to partners, they give some to us, just to make sure that we are getting as much diversity back onto our reefs as possible, has been so reassuring. And I know that The task at hand is very difficult and daunting, and sometimes I get kind of freaked out when I really think about it. But we have been able to produce resilient animals and tackle really large issues.
It looks like there could be a significant role for hyperspectral imaging in the process of culturing coral and analyzing the cultured coral in preparation for planting back into the environment.
If you want to donate money, that is huge. If you are here locally, we would love your help. We have a couple volunteers on site right now that are getting their hands wet, actually working with the coral.
Ran out of batteries, so we're kind of done for the day, and it was 90, 95, and we all kind of decided to hop in the water, and Carson had a snorkel, and he went and he swam around, and he said, oh look, there's some big coral right under us. There's this, he found an interesting crab.